All right, ladies and gentlemen, we are going to work on predicting products. The thing you will need is your periodic table and a sheet like this. But you can do this on regular notes. Follow along. There will be questions. All right, the first type of reaction we have is a synthesis reaction. It's when A plus B makes AB. You're creating one new product. Generally, they're going to be very simple. We're going to have a metal and a nonmetal to make a binary salt. So what that means is here we have a metal, here we have a nonmetal, but it's Cl2. What's the deal with that? Why isn't it Na2? Well, Cl2 because of Hunkelbrief. Those are the diatomics, okay? So what that means is chlorine will never be by itself when it's in a reaction, okay? It's either going to be bonded with something else or there will be two chlorines. However, that does not mean when I put these together, Na and Cl2, okay, that doesn't mean it's going to be NaCl2 because you have to make the compound, which you've already learned how to do. So the deal with Na and Cl is Na has a charge of +1, Cl has a charge of -1 from their locations on the periodic table. So that makes NaCl. Now the thing that's missing is the states of matter, okay? This is going to be solid sodium. If you look on the periodic table in the classroom, sodium is black. Black means solid. Chlorine is red. That means gas. And when you do a synthesis, it's going to always produce a solid, okay? Now, the one other thing I forgot to do here is balance the equation. You're not done until you balance. Let's take a look at magnesium and chlorine, okay? The only difference with this is now I have to look at magnesium, which is +2, and chlorine, which is -1. So when we crisscross, we get MgCl2. Okay, now if we think about states of matter again, this is a solid, this is a gas, and that makes a solid. The equation is balanced, so we're good to go. Generally with this, when you're forming a synthesis, okay, forming a new compound, you have to crisscross the charges, okay? And don't forget about Hunkelbrief. Our second type of reaction is a decomposition reaction. This is where you have one reactant and it breaks down into multiple products. All right, we have three special cases: metal carbonates, metal hydroxides, and metal chlorates. So you have to learn how to identify a metal carbonate. So if you see here, this is calcium, that's the metal, CO3 is carbonate. It breaks down every time into a metal oxide, same metal, so this was calcium, and oxygen. All right, so oxygen is always has a charge of -2 based on the periodic table. All right, the metal calcium in this case is Ca, and that's +2. So together, that's CaO plus carbon dioxide. Everybody should know carbon dioxide by heart. So that's CO2, okay? States of matter. Calcium carbonate is a solid, okay? It's not dissolved in water. There's no water in this reaction, okay? That leaves the other calcium substance, also a solid, and CO2 is a gas. We check to see if it's balanced, and it is, so we are good to go. If we try it again with iron carbonate, same idea, except for now, iron is the metal, and it's Fe +2 and O -2, so it becomes FeO plus CO2. You always follow that pattern, and that's what kids tend to forget. Okay, this pattern right here, metal oxide plus carbon dioxide. If you have a metal hydroxide, okay, ladies and gentlemen, it breaks down into a metal oxide, same thing, O -2, and water. Water's easy. Everybody should know that, H2O. So if we look at barium hydroxide, okay, it's going to break down into barium oxide, BaO, plus H2O, okay? I have to check my states of matter, solid, solid, H2O at room temperature is a liquid. All right, and then we have to see if things are balanced. I have one barium, two hydrogens, and I have two oxygens, and I have two oxygens. Here's another example, sodium hydroxide, okay? It's gonna make a metal oxide, but life's a little trickier here because sodium has a charge of +1. O has a charge of -2. You have to make your compounds the correct way first. So this becomes Na2O plus H2O. All right, H2O is a liquid, Na2O is a solid, sodium hydroxide is a solid. Now we got to double check if we're balanced. I have two sodiums here and only one here, so I'm going to put a 2. That fixes that. Now it's two oxygens. I have one here and one here. Perfect. 2 hydrogens, and I have 2 hydrogens. All right, so that's the pattern we follow for metal hydroxides. Our next situation is a metal chlorate. You have to be able to identify chlorate is ClO3. Okay? Metal chlorates become metal chlorides. Chloride is Cl minus 1. Okay? And oxygen, O2. Okay? That's oxygen gas. So now if I look at this, this is potassium is the metal. It's going to mix with chlorine. So I have K plus 1, Cl minus 1, becomes KCl plus oxygen. We got to look at the states of matter. Okay, this is solid, solid, gas, oxygen, it's red on the periodic table. And then we have to see if it's balanced. When I look here, my oxygens are funky. So I have 3 on this side, 2 here. So we're going to make them both 6. I'm going to make them both 6. We've changed the KCl. I can put a 2 there, and that balances the KCl. Let's take a look at magnesium chlorate. Okay, so that magnesium is the metal, so Mg is plus 2 on the periodic table. Cl is minus 1, so this becomes MgCl2. That's a solid. Okay, your reactant in your product with the metal is going to be a solid plus O2. Okay, and that's a gas. Now the only thing I'm seeing that's a little bit off is oxygen. Here I have 6, but over here I have 2. I can put a 3 there, and now I am balanced. We have one other decomp. It's a simple decomp. It's binary. I have 2 elements, Na and Cl. So it just breaks down, okay, into Na, which is a solid on the periodic table, plus Cl, except for you got to remember Hunkelbrief. It's never going to be by itself, so it's Cl2, and that's a gas, okay? Ladies and gentlemen, not balanced, so I'm going to put a 2 here and a 2 here, and we are balanced out. That's it for synthesis and decomp.